we can use an equivalent ratio table to create a coordinate graph. Let's look at this situation. Dave runs 1 lap for every 2 laps that Nicole runs. If we were going to put this into a ratio table, the first thing we would need to do is figure out how many laps Nicole runs every time Dave runs a lap. So if Dave ran 1 lap, because here it says Dave runs 1 lap, for every 2 laps that Nicole runs. That means every time Dave runs 1 lap, Nicole is running 2 laps. So if Dave were to run 2 laps, every time he runs a lap, Nicole runs 2. So that would mean that Nicole is running 4 laps. So she runs 2 laps every time. So it's almost like we take Dave's laps and we multiply them by 2 to figure out how many laps Nicole is running. So if Dave runs 3 laps, Nicole would run 3 times 2, which is 6 laps. If Dave runs 4 laps, Nicole runs 8. If Dave runs 5, remember 5 times 2 would mean Nicole would run 10 laps. And finally, if Dave were to run 6 laps, Nicole would run 6 times 2, which is 12 laps. Now this is a ratio table, an equivalent ratio table. We can use that to help us create a graph. If you look over here, we have a graph. Now this graph is already labeled. It has an x-axis and a y-axis. We can see that Dave's laps are our independent variable. That's x. And our y value going up the side here are Nicole's laps. We know that when we create ordered pairs are always a combination of values, an x-coordinate and a y-coordinate. So using this graph, we can see that Dave's laps are going to represent my x values. Nicole's laps, because they're on the side of my graph, on the y-axis represent my y values. And together we can take these two numbers and put them together to create an ordered pair. Now that's really important that you don't assume that whatever is first in your table is your x value and whatever is second is your y value. If you have a graph and if your graph is labeled, you have to look at what your independent and dependent variable is to know what should come first and what should come second. Once we figured out that x values are for Dave, we know when we write our ordered pairs, Dave's numbers will always come first, and Nicole's value will be our y value, which will come second. So the first ordered pair we have is 1, 2. In order to put that in my graph, the first thing I should do is number it. Now remember, with a coordinate graph, we're labeling the lines, not the spaces. So I'm just going to take a minute and number my x values and my y. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Another thing to keep in mind with coordinate graphs is your x value tells you how far you go across the x-axis, and your y value tells you how far you go up the y-axis. So the first number is always going to tell us how far we go to the right. Our second number is going to tell us how far up we go. So in this case, we're going to go over, starting at 0, 0, over 1 of Dave's laps and up 2 for Nicole's laps. And we'll stick a dot right here. And I'll actually do that dot in red because I wrote this ordered pair in red right here. Now let's look at another set. So we have this pair of numbers right here. Remember, our x value is Dave's laps, which is 2. Our y value is Nicole's laps, so we're going to go over 2 for Dave and up 4 for Nicole. Again, my x value is Dave's. My y value is Nicole's laps, so 3, 6. Starting at 0, 0, I go over for 3 and up for 6. And I'm going to continue this pattern for as long as I can put my points on my graph. And once I get to a certain level, I'm going to run out of spaces to put these numbers on my graph. So once that happens, I'll stop graphing. So I'm going to go over 5, up 10. Now that's the last point I can put on my graph. Anything else is going to end up being off here. But I will write it as an ordered pair. We have Dave's laps and Nicole's laps. Okay? Now this idea works even if your ratio table is set up to go horizontally. Okay, like this one. Let's look at this situation. It says Mark pays $2.50 for his school lunch every day. So for one lunch, he's paying $2.50. So let's start with our ratio table. For one lunch, he pays $2.50. Now, if I were going to write that as an ordered pair, again, we have to look down at our graph. Our x values going along the bottom here are my number of lunches. So this is x. My y values going up my y-axis is the cost. So when I write this ordered pair, x is going to come first, so my number of lunches first, and then my cost will be second. So the first thing I want to do is we'll fill out our ratio table. Then we'll go back and we'll make our graph. So if Mark buys 2 lunches, each lunch is $2.50. So that's like saying we're doing times $2.50. So 2 times $2.50 is going to be $5. If he buys 3 lunches, we've got 3 times $2.50, which will be $7.50. And then we have 4 times $2.50, which would be $10. Got a couple more here. We've got 5 lunches. If he buys 5 lunches, 5 times $2.50 is $12.50. And last but not least, if he bought 6 lunches, 6 times $2.50 would be $15. Now again, before we put these on our graph, let's number our values so that we can find them easily when it comes to graphing. There's my x values. Here are my y values. 6, 7, 8, 9, 10. And we're going to create our ordered pairs. Now we already did the first one together. We said our x value is our number of lunches because that's on my x-axis. My y value is my cost, so we had this ordered pair 1, comma 250. Well, 1, remember this first x value always tells you how far across. That's easy because we're just going to go from 0 to 1. The y value where I'm going up is a little bit trickier because it's $2.50. I have $2 and I have $3. I don't have $2.50, but I know it would be right in between $2 and $3, so I can put it on my graph right here in between where $2 and $3 are. My next set of orders pairs is 2, comma 5, so I'm going to go over 2 school lunches and up $5. My next ordered pair is 3, comma $7.50. So I'll go over 3 school lunches and up to $7.50, which remember is between 7 and 8. So it's going to be right in the middle there. And the last one I'm going to be able to fit on my graph is 4 lunches and $10. So I'll go over 4 and up 10. Now that's all that I can fit on my graph, but I am going to write these other ordered pairs out. So I have 5 lunches and $12.50. And then my last set of ordered pairs would be 6 lunches and $15. And that's how you put the numbers or the pairs from a equivalent ratio table onto a coordinate graph.